Jamal Collins buys a car costing $19,300. He agrees to make payments at the end of each monthly period for 5 years. He pays 6% interest compounded monthly. What is the total amount of each payment? And then find the total amount of interest Jamal will pay. First of all, as we've discussed before, anytime you have a loan payment problem, it's going to be a present value formula problem. So that's first thing. Got our formula written down. And then it simply becomes a matter of calculating the values that you need for the formula. The present value is always the loan amount. So he's borrowing this $19,300 to buy a car. The periodic payment is one of the things they're asking us for, so we'll be searching for that. The time in years, it's a 5-year loan, so N is equal to 5. The annual interest rate, 6%, but you want to write that as a decimal, so it'll be 0.06. Move the decimal point 2 places to the left. M is the number of compounding periods per year. It's monthly, so that would be 12 times per year. The interest rate per period, the little I, is R, which is 0.06, divided by M, which is 12. And if you can't do that in your head, you can do it on the calculator, divided by 12. And this brings up a point that I need to make sure you understand. When the calculator brings up a value like this, it has a 5 with a decimal point, and then it's got an exponent of negative 0.3. Now you need to know how to interpret this. This is the calculator's attempt to write something in scientific notation. So what it's saying is take the number in the display and notice the decimal point where it sits, and if that number is negative in the exponent, you move the decimal place that number of places to the left if it's negative. If it were a positive number, you'd move it to the right. But in the context of the problem we're going to be working, is going to be negative. So that decimal place sits 1 to the right of the number 5. So that negative 3 in the exponent tells us to take the decimal place and move it once, which takes it to the left of the 5. Then again twice, which means we need to add a 0, and yet a third time, so we have to add 2 zeros. So the bottom line is that is going to be 0.005. 0.005. Notice that the decimal point originally was here, and that negative 3 says to move it 1, 2, 3 places to the left. So that's how you have to interpret that. And if you haven't dealt with that yet, you need to come to grips with it. 5 with a negative 3 in the exponent, a calculator display, means take the number, move the decimal place. If it's a negative exponent, that many places to the left. And then finally, N is equal to M times T. M is 12 and T is 5, and 12 times 5 is 60. So now really the only thing to do is to put everything into the formula and calculate. So you get 19,300 is equal to capital R times 1 minus 1 plus, again we've calculated little I to be 0.005. That's raised to the negative n power, will be the negative 60th, and that entire amount is divided by 0.005. So let's make a little room here to actually do the arithmetic. So I've got 19,300 equals capital R times. Now let's do all that fraction in one fell swoop. 1 plus 0.005. If you want to do it on the calculator, you can, but it's 1.005. Then you want to do the power button, which is the x to the y. Raise it to the negative 60th power. You cannot type in or enter in directly a negative number in this calculator. The trick is to enter the positive value 60. There's a key labeled plus minus, and that changes the sign. So that plus minus key changed the positive 60 to a negative 60. Now if you hit equal, you'll have that base raised to the negative 60th power. The next thing you notice is that number should be negative, and it's not, it's positive. Well, that's another perfect use of the plus minus key. If you hit plus minus, you've changed it to negative, and the only thing in the numerator you haven't dealt with is this positive 1. So you simply say plus 1 equal. So that a number in the display now is the entire numerator, so the only thing left to do is divide it by 0.005. So divided by 0.005 equals. So what you end up with is 51.72556,075. Now if you're going to use that number, take it out of the calculator and put it back in, be sure to take lots more decimal places than you think you need, because you may lose accuracy in the sense if you don't. My suggestion is to not ever take that number out of the calculator, and that way you don't have to worry about it. Now looking at this, I need to solve for capital R, so I need to divide both sides by this 51.7 and so on quantity. So what I'm saying is that R is really 19,300 divided by 51.72556075. Now here's another area where I sort of do a trick to keep the number in the calculator with the minimum amount of difficulty. You could just erase everything and put in 19,300 and do division and type that number back in, but that takes a while, and if you're not careful you may lose some accuracy if you don't use enough decimal points. So I sort of don't like that way of doing it, although it works if you're careful. The other thing you could do is store that number with the memory key in the memory and bring it back out when you need it. That's fine, but there's a faster way, and that is to take advantage of this button on here labeled 1 over x. It's right next to the power button. It's actually the shift of the button next to the power button. It's called 1 over x. It's the reciprocal key, and it flips a fraction upside down. So what that allows me to do is, since I've got this nasty fraction number with a lot of decimal places in the display already, and I don't want to erase it and type it back in, what I'll do is take advantage of the knowledge that there is a reciprocal button, and I'll divide it upside down. I really want to divide numerator divided by denominator, but what I'm going to do is take denominator and divide it by the numerator, which is 19,300 equal. Now I know that's not going to be the right answer because I divided denominator by the numerator instead of the numerator by the denominator. But that reciprocal key flips it and makes it right again. So if I hit shift reciprocal, I get R is equal to $373.12 to the nearest cent. And by flipping it, I made it right again. So I divided denominator by numerator instead of numerator by denominator, but the reciprocal key corrected it. And that made it really easy to leave that number with lots of decimal places in the display and still get the right answer with the minimum number of keystrokes. You can do it differently, but that's my recommendation. So this is the amount of each payment that Jamal made on that car loan. That wasn't the only question that was being asked. There were also, I believe, 2 other questions. They also asked what was the total amount of each payment, and we got that. Now there's only one other question, and that is how much interest he paid. Well, that's easy enough. The total interest that Jamal paid is the total amount he paid minus what the car was worth. Everything, or the amount he borrowed, if you want to look at it that way, it's the same number. He borrowed $19,300. He paid in more than that. The difference between those two quantities is interest. So the hardest part of this problem now is to figure out exactly how much Jamal paid in. I say hard, it's just not really hard. So, how do I figure the total amount that Jamal paid? Well, it's again just common sense. He paid this amount every month. So he paid $373.12 every month for 5 years. So 12 months, 5 years, 12 times 5 is 60. It's really just this number right here. That's how many times Jamal made a payment of $373.12, but it's 12 times a year for 5 years. But you can see that it's just going to be this 60 right here. and if you multiply that, you're going to get the right answer. Now, another word of warning: the number that I've written down here to be multiplied by 60 is not exactly the same as the number in the display. The number in the display is the unrounded version. The number on paper has been rounded. If I multiply the number in the display by 60, I may not be accurate to the nearest cent with the same number if I just took 373.12 and multiplied by 60. And the question is, which should I use? Should I use the rounded or the unrounded? You have to think about that. In the real world, when you're really making loan payments, you're not going to pay this amount in the display. They're going to round it off to the nearest cent, and this is the true amount that you will be paying every month. So if you multiply the number in the display by 60, that's not quite right. It's what the calculator tells you, but the bank says pay me to the nearest cent. So in this case, when you're looking at a payment and you're going to pay it to somebody in reality, then you need to look at the dollars and cents version of it, not the unrounded version. So just watch this for a second. If I take the number in the display and multiply it by 60, I'm going to get something with 38 cents on the end. But let's do it the way it really needs to be done, and that is to take the rounded version, the actual amount you would really pay, and put 373.12 in there, and then multiply that by 60, and instead of ending in 38, it ends in 20 cents. And I didn't even pay attention to the rest. The point is, it's not the same because you were using the unrounded version, and you're going to get some difference there. So be careful when you're figuring the total amount actually paid to use the rounded dollar and cents value, not the unrounded value. Anyway, the bottom line is the total amount that Jamal paid is $22,387.20. That's how much he actually paid for that car. But he borrowed $19,300. And the difference between those two amounts is the interest. So if you take the $22,387.20 and subtract the $19,300 that Jamal actually borrowed, the difference of $3,087.20 is the interest that he paid. So the interest paid is just the difference between those two numbers, $3,087.20. And that's the amount of interest that Jamal paid.